So I got asked if I could take a look at the derivative of 5arctan of x on 3, and what we're going to do here is we're actually going to use a technique called implicit differentiation. So basically this is just the chain rule for differentiation. So if I want to find the d by dx of something, I can just sort of think of this as, well, it's, if my pen will work, d by dy composed with dy by dx. Okay, so what I've done here is I've just assigned this thing to be y. So what we're going to do is we're going to just take the derivative with respect to y, and then we're going to take the derivative with respect to x. So first thing we're going to look at is if we have some function tangent of z, let's just figure out how we do the derivative of this. Alright, so, well, this is going to be d by dz of sine of z over the cosine of z and what we're going to do here is we can think of this as the product of sine of z and 1 over cos of z. That's the way I do it. Maybe use the quotient rule, which is pretty much the same thing. I always prefer to just do it this way. So derivative of sine, well, 1 over cos is going to stay the same, so it's going to be 1 over cos of z, and then the derivative of sine is just cos of z. I'm actually going to leave this in this form just for now. So we're going to add on, well, sine of z is going to remain unchanged. And then just by chain rule, so it's going to be negative sine over, it should be times, negative sine of z over cos of z squared. And my pen's really not cooperating with me all that well today, so you'll have to excuse this being a bit messy. And this should be a negative as well, because we're going from a power of -1 to a power of -2, so you need to times that. So these negatives are going to cancel out, so you're going to be left with a plus here. And if we just put this all together, I'm going to times the top and bottom here by cosine each. So this is going to be cosine squared, this is going to be cosine squared. So we're going to get cosine squared plus sine squared in the numerator here, which is just going to be 1 over cos squared of z. Okay. And I'm just going to write that in. So we've just shown that d by dz tan is equal to 1 over cos squared of z. Alright, and well, I want to rethink what this is. So recall that 1 equals cos squared plus sine squared. So if we divide out by cos squared on both sides, we get 1 over cos squared. Damn, it's really not cooperating with me today. 1 over cos squared is equal to 1 plus tangent squared of z. So this is just like a neat little trig formula, and eventually we're going to come back to a starting question. So let me just take this. So, copy this, and we'll paste it here. Alright. So recall in the beginning that we said with this guy, now we know how to handle the differential of tan. So we're just going to go use the chain rule here. And I'm actually going to make a bit more space. So if I differentiate this with respect to y, I've just shown that's 1 plus tan squared of y divided by 5. And we need to remember as well the chain rule, so this is going to be 1/5 of this. And this is gonna, oh sorry, we also need to do dy by dx. Man, this is messy to do. And if we differentiate this guy with respect to x, we're just going to get 1/3. Alright, and if you so what we're going to do here is, so we've got this formula for tan of y, and this is why we worked out what this little function thing here is, or this little identity is, because notice we've got a tan of y on 5 here, and we know that this is just x on 3. So we're just going to make a bit more room first, and then we're just going to substitute that in. So we're going to get that dy by dx is equal to 1 over, well, it's going to be 5/3. Let's just bring everything onto one side. Times by 1 over 1 plus tan squared of y over 5. Alright, and this is just going to be equal to 5/3. And then we're just going to plug in our tan of y on 5 here, so that we know that's x on 3. 1 over 1 plus x on 3 all squared. And then we're just going to simplify. So in the end, we get the dy by dx is just equal to 5/3 times by, and if we just simplify this, we'll times everything by 9 on the top and the bottom. So 9 over 9 plus x squared, and then we'll just take out a 3 here, and then we'll times in by the 5 as well while we're at it. So we're just going to be left with 15 over 9 plus x squared. So that's how you find the derivative of this function here. And yeah, thank you. If you enjoyed this video, please like and subscribe. Peace.